We'll now take a look at a potential issue when we use the assignment operator on objects of classes. Let's say we have the following statement, something like my clock equals your clock. So you would think that we're taking the contents of your clock and storing them in my clock, but that's not the case. What's happening here is we're copying the memory address that's stored in your clock and storing that into my clock. So what this means is that both of these objects, or I should say reference variables technically, are now pointing to the exact same object. This is what we call shallow copying. And this occurs when we have two or more reference variables of the same type point to the same object. So in our previous example, the object that was originally pointed to by the myClock reference variable is no longer accessible because we just overwrote that memory address with the address of your clock. So whatever object myClock was originally pointing to has just now been obliterated. We can't get to it anymore. So what if we want to actually copy our instance variables instead of obliterating memory addresses? So if we want to copy instance variables, we can just create a new method in our class that will take care of copying all the contents of one object and storing it into another object. So let's say we call this make copy. So using our clock example, we would just take our hour, minute, and second variables from the current object, and we'll store them into the respective members of the other object. So I can do something like myClock.makeCopy, and I can pass your clock. So what this does is it will store all the instance variables of your clock, that object, into the instance variables of the myClock object. So this type of copying is what we call deep copying, because we've copied the contents from one object to the other, but each reference still refers to its own object. So we haven't changed any of the memory addresses. We've just changed the data. We can even take it one step further and create a method that just basically duplicates the current object, and we just return that object to be stored somewhere else. So let's say we create a method called GetCopy, and this is a method that returns an object of our clock. So we can say something like myClock equals yourClock.getCopy. So what this does is it makes a copy of the yourClock object, and then we store that in the myClock object. So here, my clock and your clock will still have different memory addresses, even though they will store the exact same instance variables. So this is another way of copying all the contents of one class into the other without obliterating memory addresses. We'll finish up the lecture by talking a little bit about the scope of the reference variables and some of the properties of methods that can be applied to reference variables. It's first worth noting that a reference variable follows the same scope rules as other variables. So if you think about all of the scope rules we talked about before, about where a variable is declared, where it's visible, that also applies to reference variables. A member of a class is local to that class. So if I define a variable within a class, I can only use it within the class itself. I can't use it outside of it unless you create an object of the class and do something with it. And then finally, when we're using methods that involve reference variables, we can pass reference variables as parameters to those methods. We've seen a couple examples already, like with makeCopy, for example. And we can also return reference variables as values to our methods. So like, for example, the GetCopy method will actually return an object of our clock class. So we can return reference variables as well.